Finding limits graphically. Today, we're going to use graphs to find limits of functions. Let's take a look at the first problem. Answer all of the questions below about the function f of x, graphed below, when x equals 1. So down here, we have our graph of f, the function that we're looking at. And down here, we have the questions that we'll need to answer. I want to do a quick review of the terminology and notation that we use for limits. The limit of f of x as x approaches 1 from the left. The limit of f of x as x approaches 1 from the right. The limit of f of x as x approaches 1, that is, from both directions, and then just f of 1. Now, what do they all mean? Let's take a look on the graph. First, I'm going to think about the limit of f of x as x approaches 1 from the left. If we kind of think of this as maybe a roller coaster, we are moving around this function from left to right on our x-axis. So if I'm approaching the x value of 1, so here's 1 on the x-axis, if I'm on the roller coaster coming from the left, I'm following this trajectory to get to the x value of 1. And as I approach 1 from the left, as I get closer and closer to 1, my y value gets closer and closer to -2. So following from the left, as I get closer and closer to 1 on the x-axis, I get closer and closer to -2 on the y-axis. And that's the limit coming from the left, -2, the y value output as we head towards the x value input. I'm going to record -2 as my output for the limit as x approaches 1 from the left. Now what about as x approaches 1 from the right? Well, maybe our roller coaster is going backwards. This coaster didn't look too safe to begin with, so what's going backwards going to do? If we come in from the right, as we approach 1 on the x-axis, we're actually getting closer and closer to a different y value, -4. So as we come in from the right, as we get closer and closer to 1 on the x-axis, we get closer and closer to -4 on the y-axis. So the limit as x approaches 1 from the right is -4. Now, since these two numbers didn't match up, we can't say that there is a limit as x approaches 1 from both sides, because they're just different numbers. So I'm going to put in DNE, does not exist. So if these two values are different, this third one does not exist. Now, f of 1, that just means what's the output when the input is 1? What's the y value when the x value is 1? So at the x value of 1 right here, it almost looks like there are two different values that y could be. But since it's a function, we know that there can only be one true answer. We need to know what these different kinds of dots mean on a graph. A closed circle includes that value, whereas an open circle just means everything close to it, but not this actual value. So 1, -4 is not actually included in our function. That's why we have the open circle. 1, -2 is included. That's why the circle is closed. So when we have the x value of 1, our y output is actually -2. The actual output here, this time, happens to match the limit as x approaches 1 from the left. Okay, let's take a look at some other special cases. This time we're focusing on when x equals 3. So that value is here. The x value is 3, and it's going to deal with this section of our function. Now, as we come in from the left, it looks like we're approaching -5. As we're approaching from the right, again, it looks like we approach -5. Since these two match, we can say that the limit does exist, and it's -5. However, the actual value of f of 3 is missing from our graph. Since it's just this open circle, I'm going to put in undefined. We don't have a value when our input is 3. It's just not something that our function can do. So the output for f of 3 is left undefined. Here's another case you might encounter. This time, we're focusing on the function f of x when x equals 5. So this graph, I'm noticing that the 5, there's something a bit strange and different going on here. Let's think about what this means. I'm still trying to find the limit of f of x as x approaches 5 from the left. So if I follow my track from the left, as I get closer and closer to 5 on the x-axis, my y value just keeps on going up and up and up. And this arrow indicates that it's going to keep on going up forever. So as we approach the x value of 5 from the left, our y value just keeps on getting bigger and it's never going to stop. So my limit as f of x moves towards 5 from the left, my limit is positive infinity. From the right, well, as I approach 5 from the right, as I come down this way, my y value, my output, keeps on getting lower and lower and lower. That limit is negative infinity. So when our limits don't match, we can just say limit does not exist. So what about the actual value of f of 5? Well, again, there is no actual value that matches up with 5. We keep on getting closer and closer to 5, but it keeps on going up and up and up. There's no actual number that matches with 5. I'm going to leave that as undefined. So let's recap some of the things that you might encounter in these problems. So I'm noticing this special case over here. If we were trying to find limits of f of x as x approaches -6, from the left, it's coming in at -1, and from the right, it's coming in at -1. So the limit is -1. But since we have an open circle, the value of f of -6 is undefined. Another special case that you might see are these arrows pointing up or down to infinity or negative infinity. So those limits could be infinite or negative infinity, and the actual value at -2, for example, is again undefined. Over here at the x value of 5, we've got something similar to what we saw at -6. The limit as it approaches from the left is 0, from the right it's 0, so the total limit is 0. But the actual output, if I plug 5 into this function, I get this outlier of 2. So we might have a function output that's an outlier from the limits. The last special case that you could encounter are these jumps, where we might have a limit approaching 6 from the left, where the limit is +1, but when we approach 6 from the right, the limit was -1. We'll have to check to see which circle is filled in, if either of them is filled in, to find the actual output. So f of 6 would be -1, but the limit from both directions, the limit without the sign, would not exist, because from the left and from the right didn't match, so the total limit does not exist. There are many different cases that you might encounter, so it's okay to make some mistakes and explore. Let me know what your questions are, and good luck.